Nice. And this was the question we looked at last class. So, cool. Let me see if I can get a question for you all before we move on, just to make sure you all understand everything.
Richie, I
Yeah,
was
yeah.
supposed to tell you, tomorrow, I'm not sure if I'll be there for admits, but I'll try to be.
Okay, no problem. Thank you for telling me.
Okay.
All right, so I have a question here, right, guys? And let me explain this question real quick. Just by looking at it, what circuit do you have? I want you all to forget about the ammeter, forget about the ammeter, forget about this, and forget about this. What kind of circuit do you have? Look at it. What kind of circuit do you have? Can you all recognize it?
Parallel.
I know it's parallel.
Justin, do you agree with the girls? They are saying parallel. Waiting for Justin. Justin, 'twas the night before Christmas. Justin was nowhere to be found.
Nah, here the Wi-Fi just keep dropping.
Oh, yeah. The girls said that this is a parallel circuit. What do you think?
Yeah.
Wait, I catch it all out here. That's
Huh?
crazy, bro. That's crazy. Okay. Let me rectify the problem there. So, Alia, the ammeter and the voltmeter tiny happens. That's what tiny happens.
Mm, mm, it's the lines for me.
Yeah, is the line right through the middle, basically.
Yeah.
What is over here?
No,
Yeah.
like the line
No,
across with 10, with the
the
10.
10, yeah.
What?
Yeah, like it's
This?
like a separate rectangle.
This over here?
Not the full. Yeah, yeah.
Yeah, not including the line with the voltage, but that 10
Yeah.
with the
Wait, let me explain something, guys. So, this is a good opportunity to explain an ammeter and a voltmeter because that confusing earlier. I know that confusing earlier. Because if I remove the ammeter and the voltmeter from the circuit, it will make plenty sense. Let me show you what I'm talking about. So I'm gonna draw that exact same circuit. I'm just gonna remove the ammeter and the voltmeter. Could somebody just remind me what ammeter measures? What does an ammeter measure?
Amps.
Amps. What is amps again? Amps is a measure of. Think about it. Look at how it's placed in the circuit. It's placed in series in the circuit. What will flow through the ammeter?
Alright.
current.
Right. So the ammeter measures.
Current.
Right. And when I talk about voltage, remember the example I gave earlier with Terrence. Terrence on the top of the building is a high place and he jumping to the ground, which is a low place. Voltage is potential difference. Is the difference between 2 points. That's why I hook up the voltmeter from this point to this point. Because I'm measuring the difference across those 2 points. That is what I'm doing there. So that's how you hook up the ammeter and the voltmeter. I'll make notes on that just now. But I had to hear all the reaction. Uh, I'm gonna do this exact same circuit, and I want to hear all your opinions. If all you stand by what I think, that's cool. But I want to hear reasons. Kira, do you still see that is a parallel or a series? What do you say? What do you think?
Well, no, it looking like a series when it was when it was over there, it looked like a parallel. Cause like
Oh,
the line with the 10 ohm, it confused me. Cause like it, I'm not explaining it.
I understand. It makes it look like the current is splitting ends.
Yeah.
Yeah, I understand. That brings me to our second point. The internal resistance of a voltmeter should be infinity. If the resistance is infinity, will any current be able to pass through?
No.
No. So that was my bad. I'll make some notes on that. I'll make some notes on that just now. But Kiara, Justin, and Aliyah, the ammeter and the voltmeter, you could remove it from your circuit if it's confusing you. Right? So just remove the voltmeter and remove the ammeter and just make a circuit. So Aliyah, you want me to explain what the question asking you now? They ask
Yeah.
you to calculate the reading on the ammeter and the voltmeter. Just remind me, what does the ammeter measure again?
Amps.
Measures no, it measures yeah, it measures amps, right? So
Current.
that
Oh,
stands for current,
um,
right? And current is something that flows through a circuit.
yeah,
And voltmeter measures what?
the voltage.
And voltage refers to the difference between 2 points, the potential difference. Right. So let me understand what's going on here. I presume you all supposed to have these notes. And you all have the notes for the ammeter and the voltmeter and how they have to be hooked up in a circuit? Let me know. You all should have those notes. Check through your notes. It should be a table or something. Like how the ammeter is hooked up, the voltmeter is hooked up. You all have notes on that?
Um, yeah,
Aliyah have it. Justin, do you have it? If not, Thelma, do you have the
Yeah.
notes, the ammeter and the voltmeter?
Um,
I
think
think it's
so.
that table. Aliyah,
yeah, and it gives,
send a picture of the notes you have.
okay. On the chat?
Yeah, on the chat. So for those who are confused, I'll make back a table here so everybody will understand it.
Oh, wait, hold on. It's sandbar.
Oh wait, you left out something, you know. You left out something.
That wasn't all?
Nope. Oh wait, no. The picture, the last picture, so I don't have everything.
Yeah,
Yeah.
yeah.
Okay, cool. Okay, I was scared for a second. Right. So the instruments we typically use is an ammeter, a voltmeter, and not necessarily a galvanometer. We don't really use that much, but it did come. It did come in 2024, so I will not leave it out like last time. Gal. Oh, you spelled that so wrong. You said galvanometer.
Yet I saw it was in the picture.
Oh, I refuse to believe that. Is it's a galvanometer. Galvanometer. Right, so you have an ammeter, a voltmeter, and a galvanometer. Justin, what does the ammeter measure again?
Amps.
No, it measures amps, right? But what is amps? Does he measure of what? That's what.
Current.
So we have to talk about what it actually measures, not the units. So the ammeter measures current. What does the voltmeter measure?
Voltage.
And the galvanometer, it shows you the direction of current, right? Direction of current. That's what it shows. Do you all know what an ammeter looks like now? Guys, do you all know what an ammeter looks like? What do you all think is the ammeter? One or two? One or two? Fast. Which is the ammeter? Kira, which is the ammeter?
One.
One, right? Simple. So the ammeter is given by this symbol over here. This is an ammeter. This is a voltmeter. And this is what a galvanometer looks like. Right. Now, let me talk about how it has to be hooked up in a series. I'm hooked up in a circuit. Justin, if we want to measure current is something that what does it do in a circuit? Like, how would you imagine current? Tell me, Justin. Like in a circuit, you would say current is what? That's what F.
Flow.
It flows. So since current is something that flows, you have to hook it up in series or parallel.
Series.
Series, because when you hook it up in series, any current would pass through it. You can see that?
Yeah.
Yeah. So it has to be hooked up in series. The voltmeter has to be hooked up in what? We want to measure the difference between 2 points. Would we hooked up in series or parallel? Kira, voltmeter, series or parallel?
Um,
You having a hard time with this one. We didn't do parallels yet, but let me explain something, right? If I want to measure the difference between this point and this point, wouldn't I draw two lines like that? I want to measure the difference between this point and this point. You understand what I'm saying?
oh, okay.
So that's how I would have to hook up the voltmeter because voltage is the difference between 2 points, the potential difference. So that's why I have to hook up voltmeters in parallel because they have to
Okay,
measure the
that makes sense. That
difference.
makes sense.
Aliyah, let me explain that back to you, right? If I want to measure the voltage across the 10 ohm, remember voltage is the difference between 2 points. So the difference between that point and the difference from that point. That is voltage. You understand? Aliyah?
Yeah.
Okay, and if I wanted to measure the voltage across the 8 ohms, would I put the voltmeter in parallel or series? I want to measure the voltage across the 8 ohms. Remind me, guys, voltage is what? What's voltage? Aliyah, voltage is what?
The amount of energy.
Now, voltage is a measure of potential difference. It's the difference between 2 points. All right? Depending on the potential difference, it will exert a force on the electrons. So voltage simply is potential difference. Potential difference, the difference between 2 points. So I want to measure the voltage across the 8 ohms, right? And that's what I want to do.
Yeah.
So I have to measure the voltage from here to here across the 8 ohms. Does that make sense?
Yeah.
All right. And I hook up my voltmeter like that. Bam. Lovely. And the galvanometer shows you the direction of current. So make a guess. Are we going to hook up the galvanometer in series or parallel? Galvanometer. It shows you the direction of the current. It deals with current. Let me hear. Use all your brain. Justin, a galvanometer. Since it deals with current, will I hook it up in series or in parallel? Can I hear him, Justin? Kira, make a wild guess. Galvanometer, is it hooked up in series or parallel?
Parallel.
Yeah, it's hooked up in, he said parallel. Wait, a galvanometer deals with what? What does a
The
galvanometer deal with?
the direction of the current flow.
Right. So if we're dealing with current flow, for you to measure the direction of the current, you're going to hook it up in parallel or series. If you hook
Oh,
it up
series.
right,
Series.
because wouldn't the current have to flow through the galvanometer for it to determine the direction?
Yeah.
Right, and the only way that will happen is in a series connection. And let we understand why. Why are we doing this? Aliyah, if you want to measure the values in a circuit, do you want the instruments to throw off the readings? Like when I put a voltmeter in the circuit, do you want that to change the circuit?
No.
No, I don't want that to change the circuit. When I put an ammeter in the circuit, do I want that to throw off the current in the circuit? Or do
No.
we want the circuit to be as it is originally?
You want it to be as the original?
Yeah, yeah. So let me look at something. The ammeter is hooked up in series. So for that not to so for ammeter not to throw off anything, it should have a resistance or what? What resistance should the ammeter have? You're hooking it up in series in your circuit. If the ammeter has a resistance, will it throw off? Will it affect the circuit? If the ammeter has a resistance, will it affect the circuit? Think about it.
No.
It will, because it will act
Oh,
like a
yeah.
resistor. Think about it there. Think about it. If the ammeter has a resistance, a resistance,
Yeah.
wouldn't it come like somebody holding the hose?
Yeah.
You want somebody to hold the hose?
No.
If you're washing the car, you don't want that. You don't want that. So the ammeter should have a resistance of
0.
0 because because look at it, you're hooking it up in series, right? And you want the current, and you just want to measure the current. You don't want to affect the circuit. So you want a resistance of 0. So the current will just flow right through it. Does that make sense?
Yeah.
So the current over here, the current over here, and the current over here, after it come out of the ammeter should be the same, right? Tell me that makes sense.
Yeah.
Cool. So you don't want to affect anything. It should have a resistance of 0. Right? Resistance. And that's ideally, yeah. Typically, most ammeters don't have a resistance of 0, but the resistance is very, very low. Kira, do you understand that? Why it must have a low resistance?
Yeah.
Right. Remind me, in series circuits, it forms a what kind of network? Starts with V. In a series circuit, what kind of network does it form?
A voltage divider network.
So if you have a resistance across the ammeter, wouldn't you have a voltage over here, a voltage over here, and a voltage over here?
Yeah.
Yeah, but wouldn't that affect the original circuit? Because and in the original circuit, and you're just supposed to have 2 voltage drops.
Yeah.
Yeah, you don't want that. You want the ammeter to just do what it's supposed to do, just measure the current, that's all. So it must have a low resistance, right? So it does not affect the circuit. Low resistance, ideally, we want to have a resistance of 0. Ideally, resistance of 0. Cool. Kiera, a voltmeter. Look how a voltmeter is hooked up, eh? A voltmeter is hooked up in parallel. What happens in parallel circuits? What happens to the current? The current does what?
Divides?
It divides. If you have current leaving here to go over here, wouldn't that affect the circuit?
Yeah.
So how much resistance it should have then? If you don't want current to flow through it, what resistance you think it should have?
Um, infinite resistance, is it? Or
Yes,
like, okay.
because if it's infinite and you wouldn't lose any current to the voltmeter,
Yeah.
you wouldn't lose any current. All the current would just pass through here. So it would not affect the circuit. So anytime you all see a ammeter and a voltmeter, pretend it's not there because it's not supposed to affect the circuit. You all feel like you understand it a lot better?
Yeah.
Okay, cool. Kira, have anything confusing? I mean, Aliyah, have anything confusing, yeah?
No.
All right. Justin, I'm gonna if you want to go over anything.
No, understanding.
All right. So Justin, why we saying the voltmeter need to have an infinite resistance?
The current to pass through.
No. Nah. Aliyah, if we have an infinite resistance, what will happen? Explain to Justin what will happen. If you have an infinite resistance, what will happen?
It would affect the current in the circuit.
What's all wrong? Kira, explain. If you have an infinite resistance, what will happen?
If you have
The current wouldn't be able to flow through the circuit.
Right. Let me understand something here, guys. We don't want to change the circuit, you know. We don't want to affect the circuit in any way. We don't want to. So do we want current from the circuit to be taken up by the voltmeter? Do we want current to flow through this? Remember, if current flowing through this, we losing current over here, you know. We losing current over here. So that would affect the circuit. So how could we fix that? If we don't want current split over here, we need to have a high resistance. So Justin, explain to me now. Why do I need to have a high resistance over here? Why do I need to have a high resistance or infinite
So,
resistance?
so yeah, current don't flow through.
Flow through the what? The 10 ohms or the voltmeter?
Voltmeter.
The voltmeter, right? Because if current is flowing through the voltmeter, okay, imagine over here you have 2 amps. Over here, over let me ask you a question, Justin. If you figure about the voltmeter, how much current is supposed to be at this point as well? If 2 amps flow in here, how much current is supposed to have over here? Wait, let me just give you another example so you understand it. Justin, if I have 2 amps over here, how much current I should have over here?
2.
2, right? Exactly. Exactly. So if the current over here is 2 amps, then the current over here should also be 2 amps, right?
Yeah.
But if I have a voltmeter and the resistance isn't high, what's gonna happen? Let me just say now you have 1.5 amps and I have zero point 0.5 amps. Wouldn't that affect the circuit?
Yeah.
Because what happened to the current here now? What happened to the current not going through the 10 ohm? What it's supposed to be? What our current going through the 10 ohm is supposed to be?
10.
No,
Oh no, 2.
2. But what happened now?
It decreased by 0.5.
Right, and that's because the voltmeter did not have a high resistance. So the current split. But if it had a high resistance, if something has a high resistance, what will it do to the current? If something has a high resistance, if you hold, Max, that question, Justin, if you squeeze the hose hard enough, what happens to the water?
And stop flowing.
It will stop flowing. So if you have a high enough resistance, what happen? Is any current gonna be able to make it through the voltmeter?
No.
No. So where all the current go actually flow then? If none of the current flowing through here, where all the current go flow?
Then
Exactly. And in doing that, it would not change the circuit.
no.
Perfect. Aliyah, you understand that well? Aliyah?
Yeah.
Okay. So Aliyah, why we need a high resistance for the voltmeter? Why do we need a high resistance? Explain. Aliyah, you're very quiet. Aliyah, you understand it or you don't understand it? Simple. Come on. Kira, you hearing me?
Yeah.
Okay. Well, I had to move on. I had to move on. So now that we understand this, oh wait, guys, one more thing, the galvanometer. Since the galvanometer deals with current and is a series connection, it's supposed to have a what? Ideally, it's supposed to have a what? Tell me fast. A galvanometer kind of like an ammeter. So it's supposed to have a what? Remember, you hooking that up in series. The way to affect anything. So Kira, the galvanometer should have a what?
A low resistance.
And if we're not perfect world, what the resistance supposed to be?
0.
Yeah, right. So let me understand what is going on. I'm gonna put in the flow of current. Actually, hear what guys, I want you all to do this question for me. The formula I will have to use is V is equal to IR. I tell them all the formula to use since all they kind of new to this, right? So, Justin, the ammeter is over here, right? Justin, tell me if you're there with me. The ammeter is over here.
Yeah.
So that is so you had to measure the current in the circuit. And the voltmeter is across which component? The 8 or the 10 ohms?
10 ohms.
Right, so you had to figure out the voltage across the
10 ohms.
right. In a series circuit, is the current at any point different? In a series circuit?
No.
No, because there's one path for current to take. One path. Right? So here what? I want you to figure out the current, the total current in the circuit, and the voltage across the 10 ohms. Give it a shot. I'll give it only 5 minutes. Take 5 minutes to try that question. And you can look back to the previous question we did to,
Where is we finding?
all right, so Kara, look at it. The ammeter is located over here. So you will have to figure out, remember, in a series circuit, the current at any point is the same. So you have to figure out the total current in the circuit. As the first thing you need to do. You need to figure out the current in the circuit. And then you need to figure out the voltage across the 10 ohms. That's what you need to do.
Okay.
So look at the previous example. Look at the previous example we did last class. So Justin, did you figure out the total current in the circuit? Or you having some trouble with that? Total current. Kiara, did you find the total current?
No.
I,
And V equals IR where like the voltage, I is like the current and R is resistance.
wait, say that again?
Like V equals IR, right?
Mm-hmm.
I is current and R is resistance,
Right, and V is?
voltage.
Yeah.
Okay.
Now let me explain something, right? If you need to figure out the total current, you gotta figure out the total what before that. If you had to use the formula V is equal to IR, right? You had the voltage, you need to find the current, and you need to find the what? You want to find the total current. So you gotta find the total what?
Resistance. Oh,
Right. Do you know the total resistance formula for a series circuit?
um,
Very
no,
simple formula. Very, very
no.
simple
I
formula.
mean, and we have two formulas where it's like V equals IR
Just
and we have the other one that is
literally just
R
one
equals
formula.
V over
Literally just one formula.
that.
Yeah. If you
Oh,
want to figure out,
that makes so much sense and it's because like and we have it because and we measure resistance in ohm. Unless I'm wrong.
say that again?
Like and we like measure resistance in ohm.
Right? Yeah, we measure resistance in ohms, yeah.
Okay. I know what to do. Go back on
So,
the question.
all right. So for those who don't know, the formula for total resistance in a series circuit is this. Total resistance in series circuits. RT is equal to R1. And it basically adding all the resistors in the circuit. It's very, very simple formula. Nothing tricky. R2 equal to R1 plus R2. Aliyah, did you find the total resistance in the circuit?
I'm doing that right now.
It's a real simple thing. I promise.
Yeah,
So we have a what kind of circuit here? Series or parallel?
a series.
How much resistance we have?
Two.
If I want to figure out the total resistance, what I have to do?
Add the 8 and the 10.
Yep, that's all. So it's the resistance, total resistance.
18.
Right, so let me understand this now. You know what the voltage is? You know what the total resistance is? We can go ahead and find for.
The current.
Yes. Yes. You can go ahead and find for the current. And that'll be the answer for the first question. And the second question marks that question, Aliyah. The current flowing through a series circuit is the current flowing through a series circuit is
Um,
watch. Did the current ever split?
no.
So the current flowing through each component is the exact same. Watch. The red line is the current. The current flowing through that. Yeah. So in a series circuit, the current flowing through each component is the same because it does not split.
Richie, if the answer we get right, how much decimal places you putting it to?
2 decimal places.
Okay.
Yeah, guys. So, answer for the first question is, let me hear, what's the answer for the first question?
I'm not sure if it's correct, but I guess like when I round it off, 0.08.
Let me tell you if that's correct. Aliyah, did you get that?
Yeah.
Both of you all will be correct.
Why you say that so unsure?
I wanted it. I want to gain the habit of seeing if all they will defend all themselves. Like defend all their answers. Y'all got 0.0833333 reoccurring.
Yeah.
Yeah.
Yeah, so that'll be 0.08 amps. Here what? Store that value in a calculator. So when you're using the value in question 2, you'll use the exact value. Do you all know how to store the value in a calculator?
No.
Okay. Do you all know how to get the answer as a fraction? That's 0.0833333. What's the answer as a
Yeah.
fraction?
Um, 1 over 12.
1 over 12, right? So here what? In the calculations for question 2, use 1 over 12. Justin, it's for having that. It's Ravi. Jeanette,
That's all.
big up Ravi. So Justin, you could do this question with me, right? You could do this question with me.
Okay.
Yeah. So Aliyah, remind me, in a series circuit, the current flowing through each component is the exact same. And why I'm saying that? Does the current ever split?
No.
No. So the current that flowing through 8 ohms is the 1 over 12, and the current flowing through the 10 ohms is the 1 over 12 cell. So figure out the voltage across it. And here what? I want you all to also figure out the voltage across the 8 ohms. Because why not? Put all it to work. So for part 2, figure out the voltage across the 8 ohms and the voltage across the 10 ohms. And I want you all to observe what you're seeing. Use the 1 over 12, don't use the 0.088 and 0.08323.
Put it as a fraction or a decimal.
Wait, let me tell you. So which one you calculate for first? The voltage across the 8, voltage across the 10.
The voltage across the 8.
Okay. You're supposed to get, let me tell you what you're supposed to get. By chance, does your answer have a 6 in it?
Yeah.
Okay, cool. Right, it's actually, yeah, right at the 2 decimal places, but write the answer as a fraction as well. You see why I'm telling you that? So that'll be 0.67, right?
Yeah, when you round it, yeah.
Cool. Find the voltage across the 10 ohms now. Kara, I want you to tell me the voltage across the 10 ohms.
Um, Before I do that, right? What was the thing for the 8 ohms? The answer
You tell me your answer.
0.6. So
Yeah.
basically 0.7.
Yep.
0.67.
Mm-hmm.
Right, okay. 0.92. That's what I get for the 10
Okay,
ohms.
I want you all to add up those two results and tell me what you get approximately.
Okay.
Wait, for the 10 ohms, I get 0.83333.
Actually, that answer make more sense, you know. Yeah, yeah, you're supposed to get 0.83.
Wait, maybe I do it wrong. Maybe I typed it wrong.
Yeah, and Aliyah, I want you to add up the 0.67 and the 0.83 and tell me what you get.
Yeah, I did it wrong. I typed in the wrong thing.
God. Um, Aliyah, I want you to add up the 0.67 and the 0.83 and tell me what you get. Aliyah,
Yeah, I don't know. Sorry.
okay.
I get 1.5.
Does that check out?
Yeah.
That makes sense.
Yeah.
Right.
But
Okay.
Auntie, would
Wait a
it be easier to just find 18 one time? Auntie, would it just be easier to multiply by 18 one time?
No. Well, here was right. Here was, Aliyah, you'd be going in circles. The question asked you, the question originally asked you to find the voltage across the Aliyah, the question originally asked you to find the voltage across
The 8.
the 10 ohms. Watch, look what the voltmeter is in the question.
Oh, yeah.
Yeah, so that is the only thing we're supposed to do. Right? But I'm
Oh,
gonna
okay.
I'm gonna add in the other part show you to prove our point. That's what I do.
Yeah.
Yeah. So I mean, why would you I guess you could do it to check if your answer correct, to see if you're doing correct. Because if you multiply 1.5 by 8, sorry, if you multiply the 0.833 by the 18, you're supposed to get 1.5. If you find the current correctly. So you gotta do that to check if your current was correct. You know what I mean?
Okay. Yeah.
Yeah, because then if you multiply the current by the 1.5, and you're gonna get sorry, if you multiply the current by the 18, then you're gonna get 1.5.
Yeah.
Yeah. So you could do that to check if your current is correct.
Okay.
So Kira, did you get the 0.83?
Yeah. And the total was 1.5. Okay. I made a mistake when I typed it into my calculator.
You have to be careful, right? But give me a second, guys. I come back. How is the washroom? All right, guys, I am back. Is everybody there? Justin, you there?
Yeah.
All right, Kiara, you there? Kiara, bust out. Guys, anybody there? Aliyah, are you?
Yeah, yeah, right too.
Okay,
Hi,
cool.
Reggie.
Hi, Kiara.
Sorry. I walked past to go and talk to my father about something. Sorry. Wait, let's
You,
call him my phone.
is that okay?
Yeah, I went to talk to him and I kicked my mother out the room because I wanted to talk to him and ask him what we're gonna get her for her birthday.
Oh, that's so sweet. When is your mom's birthday?
Monday.
Oh my God. Hmm. Well, what is Aiden gonna get her?
Does ever get she anything?
Wait,
That's a joke. I don't know. I had to talk to him too.
that's crazy. Okay, I just put any question in. Right after this question, we're gonna move straight into parallel. Since you all already understand the concept, we could go through that really quick and do questions one time. That's my hope. Until you understand everything so far, or like, are we into hopeful there? Kira, let me know. Let me know what's going on.
If we could do question two.
Now, like I do question two just yet. Like
What
I
what
do.
what what was the question you asked though?
I say I trust and all you understand this concept, so I could just
Yeah, yeah, yeah.
parallel circuits.
Mm-hmm. Yep. Mm, sure.
Okay, blessings. Um, Justin, after this, you should understand it. I hope. This is my hope.
Yeah.
Hmm. Wait, that's weird. So here's all you could get something to eat or chill in the meantime while you already understand this. All right, so Justin, let me get straight to it. What's the formula we're going to be using in this question? What's the main formula?
Um, V equals to IR.
Right. So the main formula in any circuit question, you have to use V is equal to IR. Now we start off with the first one. We want to find the reading from the ammeter. What does the ammeter measure?
Amps. Well, current.
Current. Say current. All right. And then you could say amps. But amps is the units for current. So say current. Okay. I'm asking a question, Justin. Does the current in a series circuit ever change?
No.
No. And if you're confused, we could write the circuit like this. Remind me, should the ammeter change the circuit?
No.
Should the voltmeter change the circuit?
Yeah. No.
No. Kira, I want you to tell Justin real quick why the voltmeter will not change the circuit. Why will it not affect the circuit? What do voltmeters have? Tell him fast, Kira. Voltmeters have high what? Okay, Aliyah, tell Justin fast. Aliyah. Voltmeters have high what? Okay, I guess.
Resistance.
Yeah, high resistance. Justin, remember, if it have a high resistance, no current will want to flow through here. It will just flow through the 10 ohms. Yeah.
Yeah.
Okay. So as I have simplified the circuit, now in the first question, we want to figure out the current. So to figure out the current in the circuit, let me look at the formula. The formula is V is equal to IR. Tell me something. In this circuit, what is already provided to us? What do we already have? Do we know what the voltage is?
Yeah.
Do I know what the current is?
No.
No. I'm trying to find that. And the resistance. Do you know the resistance?
Yeah.
Not so fast. We want to figure out the current in the circuit, the total current. So we need to figure out the total what? The total what?
Um.
You have
Um.
you have a 8 ohm and a 10 ohm. You need to combine those two. You need to
Yeah.
add them to figure out the total resistance.
Yeah.
Right? So let me calculate the total resistance. What is the total resistance?
18.
Right? That's 8 plus 10. That's 18 ohms. So let me show you all something real quick. You see that circuit over there? That circuit could also be drawn as this over here. It means the exact same thing. Kiara, today I went to Subway lunchtime and there was they now put the cookies to bake. And when they open that oven, boy oh boy, when I tell you that smell nice. That smell like heaven.
Okay, then, Reggie. Thanks for your lovely information I didn't ask for.
It's okay. Well, I know you don't appreciate the talk about Subway cookies.
You know, I'm not gonna eat some cookies.
Right. So does everybody, if I say that this circuit is different from this circuit, am I correct or am I wrong? You listen to what I'm saying. This circuit is different from this circuit. Is that right or wrong? I need a little stand up for the answer and be confident. Is this circuit different from this circuit?
No.
No. That's what Leah is saying. Here, what about you? Are those two circuits different?
No,
Justin, what about you?
No. Same thing.
Is the same thing? Yes. Because N8 plus 10 is 18. It means the exact same thing, guys. Don't get tired. Right, so we have the total resistance. Do we know what the voltage is? What is the voltage?
1.5.
In any question, guys, please find the total resistance first. You need to figure out the total resistance so you could figure out the total current. Need to. So here what? Now we actually find the current. The current would be equal to what over what? What would I be equal to?
V over R.
Right? What is the voltage?
Voltage is 1.5.
Resistances?
18.
Plug that into your calculator.
8.2.
Say that again?
0.83.
Yeah. Well, it's supposed to be 0.
Well,
Right?
0.083. Yeah.
We rounded it off to two decimal places, so we're gonna say 0.08. And that you could write it like that. Nah, typically in physics, you don't really write your answers as fractions, but I'll just put it in brackets because we might want to use the exact answer. It's 1 over 12 ounce. Right. So Justin, what did we just now find for? What is the current flowing through the circuit? Can you tell me? What is the current running through the circuit?
Current
Yeah, what is the current
0.
running through my circuit?
0.83.
0.08.
Yeah.
Plug that into the calculator. That's 1.5, 1.5 over 18.
Yeah.
It's supposed to get 0.08333.
Yeah, well, I just rounded up to 0.83. Well, 0.083.
Oh, okay.
My bad, my bad.
Since we're rounding it off to two decimal places, though, it'll be 0.08 because it's the first decimal place, the second, and after that is 3. So you just say 0.08. Right. So the current running through this circuit is at all these points. What is the current? At all those
Current,
points. 0.08 amps.
yeah.
So if the same current running through all my components, can you figure out? Okay, wait. Before I say anything, in the question, they wanted you to find the voltage across which component? The 8 or the 10?
And
Right, so that we actually find that.
so it is 0.08 divided by 10.
Divide by. We want to find voltage. Voltage is equal to
I divided by R.
V is equal to IR, not divide. Yeah. So here what? For this question, I'm going to use the exact value. 0.08 is really 1 over 12. So for the voltage, I'm going to say 1 over 12. That's the current multiplied by the resistance. What's the resistance?
10.
Right? What is 1 over 12 by 10?
5/6.
Right? Which is? What is it as a decimal? Decimal. Pass. Justin. Somebody tell me what is 1 over 12 by 10? It's a decimal. Justin, I seen you unmuting, but I'm not hearing you. Kirsten, you can tell me what 1 over 12 by 10 is as a decimal? Drop it in chat. 1 over 12 by 10. Aliyah, tell me, what is 1 over 12 by 10 as a decimal?
0.83.
Right. Yeah, that's correct, Kirsten. 0.83. Nice. And I mean, that's part two, but we could also add an additional question. And for the heck of it, yeah, I just add additional parts. So I'm gonna add a part three to this. So Justin, what is it that we just now found? That's the voltage across the what?
Voltage across 10.
Voltage
So
across.
it wasn't
Yeah.
here all the times.
Nah. Oh, there was here and jumped
Or
it.
No.
Yeah.
Rappi Wi-Fi. I walk into good one.
I'll tell her Rapi's upgrade. Right? And here what? I'm gonna add an additional part. I want you all to find the voltage across the 8 ohm resistor. So how would I find the voltage across the 8 ohm resistor, Justin?
0.08 divided by 8.
Why are you saying divide? You want to find for voltage. What's the formula for voltage?
We oh wait no 0.08 by 8.
Yeah, but we'll use the fraction. So I'll say 1 over 12 by 8. And what is that as a decimal? Fast. Somebody tell me what 1 over 12 by 8 is a decimal.
0.66.
Mm-hmm. Well, that'll be 0.67. Right? And just in a way to add 0.67 and 0.83 and tell me what you get.
1.5.
What was the input voltage?
1.5.
Yeah. So you see when I say a voltage divider, that's what I mean. You have the voltage splitting up across one resistor and the other resistor. So anytime you have a series network, you have voltage drops. You have different voltages at different points. Cool. That's it for series. Let me look at resistors in parallel. Finally. So, Aliyah, can you understand why I'm saying resistors in parallel just by looking at it? Just by looking at it, can you see what I mean by resistors in parallel?
Yeah,
Those two resistors are what to each other?
parallel.
Wow. I'm a smart girl in class now. Right. Not all the time it will be drawn like this. Let me show you something. I cannot draw that circuit like this. What you say? Does that look like it's in parallel? I mean, I could tell, right? How will I could tell as a parallel circuit as opposed to a series circuit? What's gonna happen? What's gonna happen in this circuit? Could somebody draw the flow of current for me? Try it. Try drawing the flow of current. I want somebody to try drawing the flow of current and see what happens. Who wants to volunteer? Aliyah, do you want to volunteer?
Sure.
I want you to draw the flow of current in this circuit and tell me if it's a series circuit or a parallel circuit. Remind me, how does
Okay.
current flows from what to what?
Current flows from positive to negative.
Is that electron flow or conventional current flow?
Conventional
Yeah,
current flow.
it's conventional. Nice.
So, oh God.
And Kiera and Justin, I want you all to tell Aliyah if she's going good.
I
Yeah.
think I had a, I'm not sure if I'm correct, though, but I think I had a like draw the current divergence.
Yes. Aliyah, if this was a road, right? If this was a road, you have cars here. When they reach this point, any cars could decide if they want to go here or here.
Yeah.
Yeah. Oh.
Oh, okay.
Mhm. But I'll give Aliyah a good explanation for something. Aliyah, if it have more resistance over here, you think, let me explain something. Let me just say it have a resistance of 100 ohms over here and a resistance of 1 ohms over here. Where would you see more current flowing? 31 ohm or the 100 ohm? Think of it like a roadblock or something. Which path has the least resistance? Which path has the less traffic? Where do you think most people would go? Through the
I1.
roads? Yeah, yeah. Mm-hmm. So show me how the current will flow in the circuit. I'm gonna remove the 1 ohm and 100 ohm, just generalize it. Show me how the current will flow in the circuit. Just show me the arrows. You know how the erase way was doing, You just left out the current
Oh,
the other direction.
okay.
Do it fast. 1 minute.
Oh gosh. Hold on, huh? It's like, oh my God, I hate this so much. Okay, sorry, hold on. Like that?
Continue. You're not finished.
Okay. Oh wait, hold on, huh?
So Kiara and
My
Justin, I will tell her when she's finished.
wait, um, hmm.
I could help her, Reggie.
If you could help her,
Yeah. Or
sure.
if I could call her.
Oh wait, look,
No,
she
it's
figured
she
it
doing.
out. She
Yes.
figured it out. Yeah, yeah, that is correct, Aliyah. That is correct. So that's how the current would flow in this circuit, right? Now let me make some further observations. Over here, the current over here would be a total current. Doesn't that make sense, Aliyah? Wouldn't I call this total current before it splits?
Yeah,
So we could call this I1. So this is I1, and we would call this I2. But when the currents meet back at this point, what would be my current? See if you can figure that out. So we start off with the total current. When I1 and I2 meet back up at this point, what would be the current?
I, um, I3.
No. You
Oh,
could call
just
it
be
I
I1.
you could call
I1.
it you could call it I3 if you want, but it don't make sense to do that. You could call it something simple.
I1 plus I2.
And what is I1 plus I2? If you add I1 and I2, what you'll get?
I3.
No, you would not get I3.
IT.
Yes, the total current in a circuit. Makes sense, right?
Yeah, yeah.
Cool. And let's just now learn KV. No, that's KCL. Yeah, Kirchhoff's current law. That's Kirchhoff's current law. It states that the current entering a node is equal to the current exiting a node. So, fancy thing. Could teach me. And Talia, she could teach me,
Mm-hmm.
right? So, I'm gonna write that over here now. So, Aliyah, the current over here, this current is the total current, IT. That's the total current. And that's the current before it.
What do you say?
IT. That's the total current before it. Before it what? Before
Before it resistance.
before it what?
Before
What happens at this point here? Can you tell me what happens at this point?
it does, hold on, it does split.
Yes. So at this point, I drew over here, the current splits. So at this point, current splits. Or let me be fancy, current divides. Right? We need to use physics language. So the current divides at that point. Okay, cool. So Aliyah, from the positive terminal, we have the total current, and then when it reaches this junction over here, it's going to divide. So what would I call the current? The purple current. That'll be I what? That's I what?
I
Look where it's
one.
passing through. It's passing through R1, so I'll call it I1.
Yeah.
And I'll call the current passing through R2,
I2.
right? And when the currents meet back up at this point, we're gonna end up with the what?
Total current.
Right. And I could write that as an equation as how I could write that if I wanted to. I could write that as,
IT would be equal to I1 plus I2.
yep, right? And this is Kirchhoff's current law. If I use words like that, and the teacher will be like, what the hell? Kirchhoff's. So Kirchhoff's current law just states that the current entering is equal to the current exiting. So let me explain. So you have the total current entering, and you have I1 and I2 leaving. So obviously, the total current will be equal to the currents are divided. Makes sense, right?
Yeah.
Kirchhoff's current law. And in this question, you saw how when you added the 0.83 and the 0.67, you got the 1.5. The previous question, when it was doing series circuits, when you add the 0.83 and the 0.67, and you had got the 1.5 volts, you all know what I'm talking about? Everybody has gone quiet.
Yeah. Yeah, we know it.
Yeah, that's Kirchhoff's voltage law, and it states that the source current is equal to the voltage drops in a closed loop. So the source voltage was 1.5, and the voltage drops across the resistors was 0.83 and 0.67, so it gave you back the 1.5. That's Kirchhoff's voltage law. Right. Now, Justin, let me understand something. In a parallel circuit, is there one path for current to flow? Tell me something, Justin. Is there one path for current to flow?
No, it could be two.
It would be two, right?
Yeah.
It would be two. So if one component goes bad, does that mean the whole circuit is gonna stop working?
No.
No. Let me give you an example, for instance. If it have 5 different routes to reach San Fernando, and one of the routes have a roadblock, and you can take the other parts,
Yeah.
yeah, the same thing over here, same thing. Literally. So if R1 blows, then this bulb will not light, obviously, because this resistor is hooked up in series with this bulb. So that will not light. Um, but the current will also be able to flow here. And you'll be able to light up that bulb. So let me ask you a question, right? Let me ask you a question. What do you all think? Wait, let me just erase this real quick. Let me see how much are they thinking, like properly thinking. If this over here is the total current, how much current do you think will pass through R2? How much current do you think will pass through R2? Would it be I2? Would it be I1? Or would it be the total current passing through R2? Let me see how much you could figure that out. Kiara.
Um,
Okay, Justin. Justin, tell me. How much current flowing through R2?
I2?
No.
Huh?
Is the current being divided? Let me understand something, right? Justin,
Oh, no. Oh, yeah.
the current is being divided, but this resistor is blown. So is that current being used up?
No, so you total would pass you R2.
Yes. Because no current go flow over here really. Because it's a
If R1 wasn't blue, and then I2 will pass you R2.
yes. Yes.
You catch me.
That is it. Aliyah, you understand that?
Yeah.
Okay. So Aliyah, if watch this, right? If R1 is blown, the current doesn't get to be used up by the bulb, right? Because the bulb not
Yeah.
lighted. So if the
Yeah.
current here not being used up, any total current will just flow through here. Think about it. This resistor is blown, so we could effectively remove it from the circuit. Watch.
Yeah.
The total current will just flow through,
Okay.
right? So in a parallel circuit, there are multiple paths for the current to flow. So if one resistor blows, the current is not totally obstructed. So like if one thing goes wrong in a parallel circuit, everything will cut off. Let me ask you a question. Um, are you think other house is wired in series or parallel? Let me hear. Kira, you think your house is wired in series or parallel? Tell me, Kira.
I feel like parallel.
Yeah, because if you want if like okay, if your fridge stop working, you want everything in your house to stop working. Remember in a series circuit, if one thing goes wrong, the whole thing goes wrong.
Yeah, I understand what you mean.
So like if a light bulb blow in your house, everything will stop working, in a serious connection. You don't want that.
Yeah.
You don't want that. So, guys, let me observe something here. A parallel circuit forms a what kind of network? The series formed a voltage divider network. What kind of network does a parallel circuit form? Justin, the series circuit formed a voltage divider network. The voltage across each resistor, there was a voltage across each resistor, right? So the voltage was divided. In a parallel circuit, what is being divided? Just by observation, what is being divided in a parallel circuit?
Total current.
So the current is being divided, right?
Yeah.
So a parallel circuit forms a current divider network. So you have the current being divided. That brings me to our next point. Kiara, if I take a voltmeter, right? Remind me, a voltmeter measures what again? What does a voltmeter measure?
Voltage.
Voltage. And voltage is the what? Is PD. What does PD stand for? Potential.
PE or potential difference.
Right. That's the difference between 2 points. I'm gonna ask that question. If I take the voltmeter, okay, remind me, how about I talk about the voltmeter again? If I want to measure the voltage across R1, how about I hook up that voltmeter? See if you get show. If I want to measure the voltage across R1, how am I gonna hook up that voltmeter?
Wait, let me see. Oh wait, I could draw. This is so cool. Um, I'm not sure. Wait, would it be like that?
Yes, that is exactly it. And
Okay.
your V will be over here.
Okay.
Right. Or you could do it like this, you know? Or you could do it like this. So let me ask you a question, right? Kira, do you think the difference between this point, okay, watch this, right? This what I draw over here. That's for R1, right? And that's for R1.
Yeah, because it's connecting to the points there.
Wouldn't it also be for R2 as well? Look at that.
Well, I guess because the divergent, the thing from R, the current from R2
No,
also
no,
going
don't
there.
worry about the current. Don't worry about the current. We don't care about the current. We're looking at the potential difference. Watch.
Okay.
When I put the voltmeter and I'm measuring the difference from here to here.
Yeah.
So wouldn't the difference from here to here also be the same?
Oh, yeah, because the parallel is the same.
Watch.
Okay, yeah, it makes sense.
So I'm asking a question. In a parallel circuit, the current changes. What happens to the voltage? What do you think happens to the voltage?
Okay, so in a parallel circuit, the current changes, but the voltage remains the same.
Yes. Think about your house. All the appliances running on the same voltage, you know. All the appliances running on the same 120 volts or 105 or 110 whatever it is. Yeah. Aliyah, you want me to explain that back for you again?
Yeah, please.
All right. So Aliyah, what is a voltmeter? When I hook up a voltmeter, I'm measuring the difference between 2 points, right?
Yeah,
So if I want to measure the voltage across R1 and I go hook it up like this,
yeah,
okay, could I hook it up like this as well?
yeah,
Yeah. Could I hook it up like this as well?
yeah,
Right. And I want you to notice something. Isn't that also the same thing from that to that point? Isn't it also the
yeah,
same difference from that to that point?
yeah,
So when I measure the voltage from here to here, is the same as measuring the voltage from here to here. Watch, because they
mm-hmm,
connected here. They connected.
yeah,
So the voltage across R1 will be the same for R2. You understand that?
yeah.
What's the difference though? Both of them go have what?
The same
Same voltage, but
voltage, but different current.
yes, different current running through them. You understand?
Yeah,
So that we summarize. In a series circuit, right, we're dealing with a series here. Justin, tell me what you have in our series. In our series circuit, what are the observations? And don't look at your book. See if you can remember it from your head. Justin, what are the observations for a series circuit? Series circuit.
Um, the total current will flow in one area, one path.
One part. So the current across each component is the well, I said that as don't I say real stupidness just now. You never say current across. Current is something that flows through. So the current through each component is the tell me, Justin. In a series circuit, you only have one path for the current to flow. So the current through each component is the come on, you can figure this out. Justin?
Yeah.
Yeah, series.
Mm,
Look at the example. What was the current passing through eight again? What was
current
the
passing through eight.
yeah, what was the current passing through the 8 ohms?
1.5.
No. 1.5 is the volts,
Oh, no, 0.08.
right? And what was the current passing through the 10?
0.08.
Right, so for a series circuit, the current only has one
One
path
part.
to take. So that means the current through each component is the
Same.
right. The current through each component is the same. What changes though? What changes? What kind of network does a series circuit form? It forms a what?
Of voltage divider because the voltage is split up.
Right, the voltage is divided, it's split up. Each resistor has a different voltage. And if one component goes bad, what happens to the circuit? If one component goes bad, what happens to the circuit?
Stop working.
Right, one component goes bad, the whole circuit stops working. I'll give you some time to copy the song just now. Right, and Aliyah and Kiara, I want you all to help me note down the observations for parallel circuit. For parallel circuit, what are the observations? Aliyah, when we looked at the parallel circuit, what was he seeing? What was he seeing for R1 and R2?
The voltage was the same.
Would I say voltage through or voltage across?
The voltage, um,
Does voltage flow through or flow through?
across.
Across. Because when we measure in voltage, it had to be the difference between 2 points. So across.
Yeah.
Yes. Don't say that stupidness, sir. I'll fall out. Don't say that. My lecturer say that. And I was about to stop. She asked, what the hell you just now say? I was about to do that. I didn't. Should I tell she? Should I tell she?
Yeah, she teaching you the wrong thing.
Boy, oh boy. Right. So in a parallel circuit, the voltage across each component is the
Same.
right. So the voltage in your house is the same. The voltage in one plug is like all the plugs in your house are the same voltage. That makes sense, right?
Yeah.
Yeah, because it hooked up in parallel. And it forms a what kind of network?
Mm,
Kiara, what kind of network does a parallel circuit form? What divides in a parallel circuit?
The current.
Right. Current is what gets divided in a parallel circuit. So it forms a current divider network. And well, if one component goes bad, does the whole circuit stop working?
No.
No, because there are multiple parts of current to take. If one component goes bad, the circuit does not stop working. So in a series circuit, you have one path for current, and for parallel, you have multiple paths. So that's the easiest way to tell them apart, no matter how complicated it looks. If all is in more than one path, parallel circuit. Right, so you're gonna copy down this summary after this. Yeah, the formula for this one is a little more complicated. It's a little more complicated. So copy this down, guys. And we're gonna do one question and that'll be for the night. And I'll give all you a homework question. That's a little hard. Kira, I know you say you had a bus out. Try to copy this down fastly. Resistors and capacitors.
Yeah, I'll try and after this I will leave, but I will watch it back to see the question.
No problem. It's the same steps, you know. You had to find the total resistance first, find the total current. It just gets a little harder when you have to figure out the current. But Kiara, what we know about the voltage across R1 and R2? The voltages will be the
Same.
yes. Aliyah, is there anything at all confusing you? Anything?
No.
Okay. How much I have to pay to go in the circus?
I think the ticket was like $150.
Wait,
Yeah.
I feel like Aliyah's the clowns. I'm joking, I'm joking. I would honestly pay that because I mean they don't really have any circuits in Trinidad, so they could charge whatever price they want. Because where else they gonna get a
Yeah.
circuit? I mean, that's circus.
Yeah, but like they were still overpriced because one hot dog is $30.
Say that again?
I know, right?
Say that again? Say that statement again?
One one hot dog is like $30.
Nah, that's crazy. I would have
It
gonna
is.
buy my sausage
And
and I would have bring my
and
something.
a popcorn is $30. Like a small movie bag popcorn is $30. A small bowl of fries is $30 too. They too ridiculous.
That's crazy.
Yeah.
Okay, Rajiva going.
Thank you for coming to class today.
You're welcome.
You know,
Bye.
it's been good today though. I find. Yeah. Right?
So
So
I make more 50, I'm 100.
listen,
I make more 50, I'm 100.
say that one more time.
He
I
said he
make more
making
50 and
50 and
100.
100.
You get 50 out of 100.
Oh my God.
No.
He make
I cannot def again. Oh, okay, on.
Runs.
Oh, you make 50 out of 100 runs.
No,
no, he make
50,
100.
50, 50 in one match and 100 in the next match.
Oh, and that's good. I really don't know about cricket, guys.
Well, the 100 wasn't me alone, it was a partnership, but I make most of it.
Like 70.
Yeah, around it.
Big up.
Because we had a 3-day match, so one day I make like 50 something, it wasn't that good. Then the next day I make 50, and the last day I make 100.
And again, I don't know about cricket much, but big up yourself.
Yeah. And well, Monday we have a little indoor um class competition, so I'm gonna try and make a little 40 something because it's not really much out.
Hmm. You go match it up. Easy man. Easy
I'll
next.
try.
Easy next. Bravo. Yes.
Nah, next Quran.
Yeah. Easy next. Pura.
Yeah. I don't know his number there already.
You have your number?
Yeah, my number is 29. He number is 29. My birthday is 29.
Oh, I thought you have it. I thought you had his number on your phone.
Nah,
I
nah.
Oh my God.
That would be a dream, but
I
me
seen
is so
every
famous.
time on TikTok and thing like two straps on it. I'm like, what? People do this in Trinidad? That's crazy.
Oh my God.
I was like,
I
wait,
feel like yeah, I love Quran.
what is it?
What?
No?
What?
I feel like yeah, I love Quran. I feel like she's what cricket for.
I think you love Pura.
No, not like that.
Oh. Anywho, I'll copy down on the diagram. I'm gonna do one question. That'll be it.
It's done 9 o'clock.
Yes, the question is not hard. I just need to do one example with you all. One example. Um, Timer. We're gonna take 10 minutes for the example for the most. 10 minutes to the most. Copy down that. So guys, I'm asking you a question. Aliyah, if I want to figure out the current through R1, Aliyah, you there?
Yeah.
I want to figure out the current through R1. Wait, before I do anything, before we do anything in any question, we gotta find the total watts. You gotta find the total watts in the circuit.
Resistance.
And then using the total resistance to find the total watt.
Current.
Right.
No, voltage. Yeah,
Yes.
current.
Yes. Once you have the current and the voltage, you can find for anything you want. Now, in a parallel circuit, the voltage across each component is the voltage
Same.
the same. So we know what V for R1 is, and we know what V for R2 is. Once we had the once we have once we had the voltage and the resistance, we could find for the current. I'll show you another formula next class, the current divider formula. But in this class, I'll just show you it with Ohm's law. How far along are you?
I only on the second diagram.
I'm gonna talk. Yeah, how much more you gonna have to copy down again? Um, Aliyah, Justin,
Yeah.
how much more you gonna have to copy again?
It's still in the secondary round.
Oh my, serious?
Yeah.
Okay. Yeah, Aliyah, how much more you have to copy down?
On the equations.
Okay, nice. Yeah, nearly finished. Copy that done. No, no, no.
Yeah.
All right, so you have a copy down.
On the last line,
All right, Justin, what about you?
On the second equation, RP.
And RP just means what? See if we can figure it out. If RS means resistors in series, what does RP mean?
Resistance in parallel.
Yep.
Also, you see, I might get thing promoted to a red force.
What?
Cricket.
You're
A
gonna get
cricket club,
promoted.
man. I might get promoted to red force.
What do I mean? I don't know about.
It's just a national cricket team. I might get promoted to it.
Okay, okay, nice, nice. So like
If
you
I
got to
do,
get that.
yeah, if I do good in this match coming up, yeah, I'll get promoted.
All right, nice, nice. You got through, got through.
So I just waiting for the coach, to let me know, and hopefully I get in.
Which coach? From Shiva Boys?
Nah,
Ah,
maybe if you know Keshiva from Val,
Rampol. Keshav
yeah,
Rampol?
yeah,
Nah.
he used to train the Jamaican Tallawahs, and
Oh, nah, I don't know. I don't know.
yeah, he's my coach. I just train with you.
Oh,
Yeah, so if he say if I make at least 50 to 70 runs match, yeah, he go promote man. But
what show you got? Me a big cricket sound singing. Yeah.
I try.
So, um, Ali, I have everything copied down there.
yeah.
So, Alia, Justin gonna be a big cricketer. I gonna be a big, like a big educator. What you gonna be?
Big supporters.
Okay, okay. All right. Or Bryce gonna be a big clown. No, 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 he not. Bryce, I can imagine Bryce being a real big technician. Yeah, I can imagine that.
But I
I
see
don't see
Ali, I
it.
know my game on them.
You don't see it like fixing, like fixing up music in car, like with car amps on.
Yeah, 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 yeah.
Yeah.
What you had to say, Justin?
But I see you want to see my cricket game on them.
Oh yeah, don't worry.
Well, you'll get free ticket on them, don't worry.
Okay, okay. Say this, right?
If I make it, you make it yet.
I gonna
Don't
make it.
worry, you can make it
You will make it. There's
for
no other
sure.
option. There's no other option than reaching your goals.
Exactly.
Try it. I'll try my best.
It's like a series circuit, you know. You only have one part to go on, and you had to go on that one part.
Nothing else.
Thing else. You can't
Yeah,
diverge. You can't diverge. You can't be in a parallel circuit. Don't be in a
nah,
parallel.
nah.
My attention span like a parallel circuit though is always diverge. One
Oh my
way.
God,
Same.
that's so true.
All right. So you will have that copy down.
Yeah.
Okay. Let me do a question. Let me do one question and then call it a night. Right. Calculate the readings on both ammeters. So I'll should understand the concept and thing by now. Let we piece together everything. So the current The current that A1 is measuring, that would be the what current? Could somebody tell me?
Total current.
Yes, yes, that is correct. That would be the total current. Alia, do you agree?
Yeah, we total because it comes straight from the positive
Straight from the source,
thing.
straight from the
Yeah.
1.5, right? This over here would be what? They would just call this resistor 1 and resistor 2.
I1
Right? I1, these are I2.
and I2.
Awesome. So calculate the readings on both ammeters. Here was the first thing you have to do. You have to convert. Yeah, okay, you have to find total resistance in the circuit. That's what you have to do. You have to find the total resistance. So you have to combine an 8 and 10. Is this a series circuit? Tell me, Justin, fast. Is this a series circuit? Is my current going in one direction?
No.
No. So what formula we had to use if we're dealing with a series circuit to add the resistors?
Can you repeat that?
What's the formula we're going to use to find the total resistance?
V plus R.
Wait, no. For
Oh wait,
series,
no.
you
I
use you use R1 plus R2 plus R3. For this one, you're going to use the formula 1 over Rp is equal to 1 over R1 plus 1 over R2, etc. So this formula is a bit harder. Good bit harder. Let me show you how to use it. So I want to figure out the total resistance. So 1 over Rp, I will have to find that. So Aliyah, how much resistance do we have on this circuit?
2.
Right, so the first resistor is,
8.
right, plus the other resistor is, that'll be plus 1 over,
10.
okay.
So it'll be 1 over 18.
What? What?
No, well,
Oh my, no, 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 no. Hey.
so what's the point in having 1 over 1?
These two
Like,
have two different denominators, so you have to find the LCM.
oh, I'm so stupid.
Understand why I react the way I react, right?
Yeah.
Okay, cool. Once you understand, plug 1 over 8 plus 1 over 10 in the calculator. What is
9
1
over
over 8?
40.
What is it?
9 over 40.
Right. Cool. Now, I have 1 over Rp, but I want to find Rp. So, Justin, what would I have to do to this to find Rp?
Inverted.
I would invert it. So I would invert this side as well. So Rp is just equal to,
40 over 9.
that's it. That is it. What is 40 over 9?
4.44 recurrent.
So that'll be 4.44 ohms, right?
Yeah.
Now let me explain something. When you added these two resistances, was the total resistance higher or lower? Let me ask you a question. In a series circuit, when you add the resistance, do you get a bigger value or a smaller value? Let me look at past examples.
Bigger value.
Yeah, watch 8 and 10, 18. Well, look at this one here now. It's kind of confusing. Watch 8 and 10 and you're getting 4.44. Huh. Hmm. Aliyah, something weird there, ain't? Something weird, something going on there, right? And
Yeah.
the reason for that is because in a parallel circuit, and you have two different paths you could take, wouldn't that reduce the resistance? Think about it. If the resistance is plenty over here, and I could just take this path, Aliyah, think about that for a second. If the resistance here is really high, and I could just take this part,
Yeah.
yeah, like if the resistance here was 1 million ohms, 1 million ohms, right? And
Yeah.
and hardly any current go past through here. and hardly any current go pass through here.
Mm-hmm.
Most of the current go pass through here, right? So the resistance could be like it could be 8 something. Let me show you. Let me show you how cool this is. So that'll be 1 over 8 plus 1 over, is that 1 million? Yeah, it is. I want you to plug that into your calculator. 1 over 8 plus 1 over a million. Try that.
What?
1 over 8 plus 1 over a million, and then I want you to flip it.
0.125001.
Just like that.
Yeah, I got the same thing.
So 1 over 8 plus 1 over a million. And I want you all to take that answer for me and flip it. Flip the fraction. So whatever the answer was for 1 over 8 plus 1 over a million, I want you to flip the answer.
It's not thing in. Hold on.
Wait, something
It's
else
not.
you all wait, there's something else you all could do, right? If you want, you could take your answer and you could raise it to the power minus 1. Math students will know what I'm talking about. If you want to invert something, you can just raise it to the power minus 1. So the answer is 0.125001. You all could raise that to the power minus 1 and tell me what to get.
I guess 7.9999.
So Watch
Nine
how,
nine.
watch how that makes sense earlier. Watch how that makes sense. Because the resistance here is so big, crazy big, most of the current will just pass through here. Like, so this is the resistance in the circuit, more or less, because all the current gonna pass through this. So the resistance is just 8 ohms. Does that make sense?
Yeah.
So, Justin, let me explain that, right? Justin, if you have if this resistor here is 8 ohms and this is a million ohms, you're probably thinking, well, that resistance should be real high end. And that's what you're thinking.
Yeah.
But no. If imagine you have a hose, right? You have a hose here, right? You have a hose. And then we just say this hose have two different parts. So and water flowing here and water flowing here.
Mm-hmm.
Okay. If you squeeze here really hard, will any water come out?
No.
Well, the water will come out then now.
From that part,
Right. So the resistance here is really, really big. So all of the water went through this path. You understand?
oh, yeah.
So the resistance for this circuit, even though this resistance here is really, really big, and the water passing through here though.
Mm-hmm.
Yeah, so I'll just worry about that resistance. So that's why the total resistance is actually less in a parallel circuit because you have multiple paths to take. So less resistance. Think about it. If you have if you have a four-way lane highway, and you got less traffic than a one-way lane highway or a two-way lane, watch. If you have a highway, right? And on the highway, you have 2 lanes versus if you had 3 lanes. Which highway would have less traffic? The one with the 2 lanes or the 3 lanes? If all you had to say.
Feelings?
The 3 lanes would have less traffic because you have more parts for the cars to take. You could have a one for slow people, fast people, medium people. Yeah. Right. So I hope all you understand that concept. So Aliyah, in a parallel circuit, the combined resistance is actually smaller. You understand?
Yeah.
It kind of hard to grasp, but that's the case. If you like you understand the concept
Yeah, a little bit.
a little bit.
No, yeah, I understand.
So So the way to say it is current actually takes the path of least resistance. That's it. Current takes the path of least resistance. So here what? Now that we know the total resistance, I'm gonna just draw back the circuit real quick. I'm not gonna draw anything too fancy because I know it's late. This is what I could draw the circuit as. And I want you to tell me something. Are the two circuits equivalent? Is this circuit the same as this circuit?
Yeah.
Yeah, because and 8 plus 10, if I combine them in parallel, and they're gonna get 4.44.
Yeah.
Cool, cool. So here what, guys? We know what the total resistance is. Can we figure out the total current?
Yeah.
Yeah.
Right. How do I figure out the total current? Current also,
Current is V over R.
right. What is the voltage?
The voltage,
Yeah, it's 1.5, and my resistance was 4.44, right?
mhm.
So I'm gonna tell you all the exact answer. The exact answer should be 1.5 over 219. So the exact current should be 0.3375 amps as the exact current. And if I round that off, I'll get 0.34 amps. Just confirm that you're getting that.
Yeah.
So here what? Now that I have the total current and total resistance, and I have the voltage, I could find for anything in my circuit. I could find for anything. So let me go ahead and find for current, find for I1. So let me find for I1. Finding for I1. Remind me earlier, in a parallel circuit, does the voltage across resistors change?
No.
No. So where's the voltage across R1?
1.5.
Where's the voltage across R2?
1.5.
Right. So we know the voltage then. We know that the voltage is 1.5 volts across all components because it's a parallel circuit. Do we know what the resistance for both of the circuits are?
Yeah.
So the R1 is equal to 8 ohms. So if I want to find the current in I1 will be equal to V over R. So my voltage is 1.5 over 8. What is 1.5 over 8?
Um.
You should get 0.1875.
Yeah.
Right, and let we find the current for I2, because why not? So I'll giving you all to do that real quick. Find the current find for I2. What is the current for I2? So you know
I guess 0 point. Okay, sorry.
you find the answer for I2 already.
Yeah.
Tell me how you do that. How did you find the current for I2?
The current could be equal to V over R.
So where the voltage
So,
across 5, and where's your resistance?
right, 10
Right? So I2 will be equal to 1.5 all
over
over
10.
the way you got.
And that'll give you 0.15.
Now here I want you to do for me. I want you to add the 0.1875 and the 0.15. And what should I get? What should I get?
Um,
What was the total current in the circuit?
0.1, no, 3, 0.3375.
Right. So this is my total current here. So here what I want to do for my way to add I1 and I2 and tell me if you get it 0.3375.
Yeah.
Yeah. And that's an example of Kirchhoff's current law, Kirchhoff's voltage law. We dealing with here, current or voltage.
Current.
Right, so that's KCL. The
Mhm.
next class, I will show you all the other method to find for current. And that's the method where we use IT, right? But for this question, the only thing you really had to find for, you just had to find the total resistance, and from there you could have figured out everything else. Because you know the voltage. In a parallel circuit, the voltage across each component is the same. You know that, right? Right. So I will see you all next class. I'll see you all next class. I'll give you all a question for homework, right? But take care, guys. Hope all you have a blessed night. Thanks for coming to class. Later, guys.